Characteristics of functions. So we are trying to understand some trigonometric functions here. So the example before us is, for the function f of x equals to tan x, where x belongs to real numbers, state the zeros for x between minus infinity to plus infinity. That means all the set of real numbers, right? Now, what is tan x? Tan x is ratio of sine and cosine, right? And I hope you remember the graph for tan x. It is kind of like this. It has vertical asymptotes. Let me start with tan x like this. So we have tan x, which is ratio of sine x to cos x, correct? Now, if cos x is 0, then tan x is not defined, correct? So if cos x equals to 0, then tan x does not exist, right? Or it is not defined, right? So where is cos x 0? Cos x is 0 at pi by 2, 3 pi by 2, right? All those values. So basically at those values, we'll have vertical asymptotes. So let me draw these vertical asymptotes. These are the points where cos x is 0. Also minus pi by 2, correct? Cos is an even function, and so it is symmetric about y-axis. So its zeros will be like similar, right? Both sides. So kind of we have these as the vertical asymptotes for tan of x, because at these points cos x will be 0. Now if this is 0, then what are these points? These vertical asymptotes are at pi by 2, then 3 pi by 2, 5 pi by 2. On this side, minus pi by 2, minus 3 pi by 2, and so on. So these are the vertical asymptotes. So tan x is not defined at these points. How does it look like? You will find that tan x is always increasing. So in general, tan x can be drawn like this, right? So we are not being very accurate here, but we're kind of giving you a way it should look like, right? So basically, you know, tan x is this pi by 2. So tan x is like an odd function. It is symmetric about origin, like sine, right? So it's like odd divided by even. So it is an odd function. Why am I telling all this? Because we are also talking about characteristics of functions. So I thought I'll share some more information with you on this, right? So basically it looks like this. I know I've made these much smaller than it should have been, but well, so it will be kind of like this. Do you see that? So they should have been distant apart, but you know. So look at it. So this pattern is going to get repeated, right? All these are pi by 2, 3 pi by 2, like that. So pi apart. So what is the time period of tan x? Time period is pi. So all these points are pi apart. That way, I think it'll be easier for us to understand, right? So it'll be kind of like this. So this is much bigger than I intended to. Anyway, the scale makes the things clearer. So basically what we have here is, we have the tan function, which we see is increasing, and it has some zeros. Zeros are these points where it intersects the x-axis. And you'll find that the zeros are at 0, and then next is at pi, between pi by 2 and 3 pi by 2, right? And then at 2 pi. Similarly, on the negative side, negative pi, negative 2 pi, and so on. So we find that the zeros for tan x are at 0, pi, 2 pi, 3 pi, and on this side minus pi, minus 2 pi. So in general, we can write this as n pi. So zeros for tan function are at n pi, where n belongs to a set of integers. So that is a general expression which will give us all the zeros for our function tan x in the interval minus infinity to infinity. Since n can have all the values, like from minus infinity to plus infinity, numbers plus minus 1, plus minus 2, plus minus 3, and so on. Do you get it? So that is how we can answer this question. Okay, I'm sorry for this. This is not to the scale. It should have been much smaller as the others are, right? But remember, time period for tan is pi. So it repeats after every pi. So that helps us to get the answer. I hope you understand and appreciate it. Thank you.